Today we will be changing B on y equals mx plus b and on applied situations. The first thing we want to do is review over what proportional relationships are talking about. Remember that proportional relationships have the following qualities. Do you remember what they are? Tell me about the slope. Remember, the slope is the constant rate of change. If it's not constant, then it's not proportional. But the slope is positive for a proportional relationship. The slope is positive, and the line passes through the origin, which is 0, 0. Another name for a proportional relationship is direct variation. So a direct variation would also have those same characteristics. The slope would be positive, and it should pass through the origin. So let's look at the very first problem. It says, for this graph, Melinda is driving home at a speed of 80 kilometers per hour. She needs to slow down. Her distance from home is shown on the graph. What is the y-intercept of this graph? So let's first look at the graph and look at the y-intercept. Remember, the y-intercept is where it crosses the y-axis, and so that would be 0, 400. And then it says, what would happen to the graph if the y-intercept were increased by 40? Well, increasing the y-intercept says it's going to go from, the y-intercept was 400. Now the y-intercept has been changed to 440, so this is the new one. And so what's going to happen to that? Did the speed change at all? No, the speed didn't change, so our new y-intercept would be here, and our speed would be the exact same, which means our line hasn't changed slants at all. And so then we would just have that same slant of the line, except that this time the line has just moved up. So we're going to say that when it says what would happen to the graph, the line would shift up 40. So what I did is I drew a new dot on the y-axis at 440, and the slope didn't change, so we have two parallel lines because the slope hasn't changed. And so you can see that since the slope didn't change, the only thing that happened is just that we moved up a little bit. And when we moved up a little bit, we would just say that the line shifted up 40. The terminology that we use for this is either shifted up or translated up. Letter C says, what would this increase of 40 mean in our situation? Well, if she is starting at 400 to begin with, and we change it to 440, then that means that she is actually starting at 440 kilometers from home. Now, letter D says, if the y-intercept were halved, what would the new y-intercept be? Well, what does that mean, halved? Well, we take that 400 and we divide by 2. So the new y-intercept is 200. And so we would write 0, hello, let's see if you can see that, 0 and 200. So that's your new y-intercept. And what would be the effect on the graph? Be sure that you're paying attention to whether it's talking about the actual number or the graph. In this one, it's talking about on the graph. So let's draw a new line on the graph. We're going to start at the 200. Did we change the speed at all? Nope, we did not change the speed. Therefore, the line is going to be the same slant as the others. It's going to still go down 80 per hour. And so you see that for this one, the line, the only thing that has happened is that the line has shifted down this time. So we would say that the line has shifted down And since it started at 400 and now it's starting at 200, we could say that it shifted down 200 kilometers. Or we could just say down 200. What would this mean in our situation? Well, remember that place on the y-axis is where she's starting from home, the distance she's starting from home. And so now she would be starting (200 kilometers from home. Great job. Now that you can see it. All right, so letter G says Ronnie drives home at the same rate as Melinda, but he lives 300 kilometers away. Describe how the graph has changed. Well, let's look at where 300 kilometers away would be. Here would be 300 kilometers. It says we're driving home at the same rate, which means the slope has not changed at all. So again, we're going to have that same slant on our line. We're just starting at 300 instead. And so if we're talking about how it's changed based on the original 400, then we're going to say that the line has shifted down and if it was 400 and it's now 300, then we have shifted down 100. All right, letter H says, does this graph represent a proportional relationship and give evidence to support your answer? Well, remember, a proportional relationship says that we need a positive slope. Does this line represent a positive slope? Nope. So it's no positive slope. Also, a proportional relationship says that it has to go through the origin. Is this one going through the origin? Nope. Not going through the origin. So if either of these things don't work, that means that it is not proportional. If we had a positive slope but it didn't go through the origin, it would still not be proportional. Or if it had a positive slope but it did not go through the origin, then, or vice versa, then it would not be proportional. It has to have both of those things for proportional. All right, let's move on to the next page. On the next page, just like when we did on the changing M, we've gone now from a real-world example where it might seem a little bit easier to understand, now to just plain equations. So we're going to use that same thought process when we talk about the just plain equations. So remember, we're talking about a slope-intercept form. We've got y equals mx plus b. And it's asking for the parent linear function again. Remember that equation for the parent linear function is y equals x, where m is 1 and b is 0. And so we look at the table of values, and remember, if the x is negative 2, then that means that the y is negative 2. The same with each one of these other values. Now, in order to graph this, we're going to start at the negative 2. I apologize for the graph. Negative 1, 0, 0, 1, 1, and 2, 2. And then we can draw our line. Notice that this is the exact same information that we had on the change in M, so the parent linear function will always be this equation. It will always have a table where the x's and y's match, and it will always have a graph where it goes through the origin and it has a slope of 1. Now, as we look at the next part, it says when you change the y-intercept, or your b, it changes the starting value of the function. Well, let's think about this from the last thing that we just did. What happened when we increased the y-intercept? It shifted up. What happened when we decreased, where it went from 400 to 200? What happened to the y-intercept? It shifted down. So as you can see at the bottom of the page here, when you see a b that is bigger than the original one, that's a shift up. If you see a b that is smaller than the original one, then that is a shift down. And so let's look at number 2. It says, how would the graph of 4x minus 1 change if the y-intercept was changed to negative 5? So let's identify, first of all, what part of the equation is going to change. It's the b. Remember, the y-intercept is your b, so it's this that's going to change. So it's going from negative 1 to a b of negative 5. Now be very careful when it comes to your negative signs here. What I would do is draw a small coordinate plane and just put your y-axis little marks on there. And if we're starting at negative 1 and we have to go to negative 5, then that means we're going down. And whenever you want to decide how many you're going down, you just count. So we would go down 1, 2, 3, 4. So this one, the line, since it's talking about how would the graph change, the line has shifted down 4 units. So this would be the answer. The line has shifted down 4. On number 3, it says, what is the effect on the graph? Again, the effect on the graph, talking about shifting up or shifting down, of y equals negative 2x minus 3 if the new equation is y equals negative 2x plus 1. Well, if we look at these equations, we have to decide what's changing. Well, in the first one, the y-intercept was a negative 3. Now the y-intercept is a 1. So we're going to say it was negative 3. It's now 1 for the y-intercept. So let's go ahead and draw ourselves a little coordinate plane over here. It was negative 3. We now want it to be to the 1. So that means we're going to have to count up 1, 2, 3, 4. So that means that the line has shifted up 4 this time. Now let's go ahead, before we do that last one, let's look at our calculator and see how that looks in our calculator. So as we look at the first one, this one here, the y equals 4x minus 1, we're typing that in, y equals 4x minus 1. And then the new one, we're going to say it's going to change, the y-intercept is going to change to negative 5. Did it tell us that the slope was going to change to a different number? No. So we're going to keep that 4x, but this time we want a negative 5 in there. So we have 4x minus 1, now 4x minus 5. If we go to the graph, let's see what happens. Here's the minus 1. Here's the minus 5. You see how the first one is higher up on the y-axis than the other one is. You can see that it has gone down 4 spaces on the y-axis. So it's very similar. Our graph is very similar to the places that we talked about here. It was on the negative 1. It went to the negative 5. Let's look at the next one. Let's type in those two equations. And so our first one is negative 2x minus 3. And our second one is negative 2x plus 1. Remember, the first one that we type in is going to be the first one that gets graphed on the paper, or on the calculator, excuse me. And so if we're looking at this, we press graph. Here's the first one, that's the plus 3. Here is, the minus 3, and then the plus 1. So you'll see that this first line was the plus 3, and it shifted up, our whole line shifted up to the positive 1. Now let's look at number 4. It says, given y equals x minus 4, what is the new equation if the y-intercept has decreased by 4? Okay, so we're taking that y-intercept of 4, and we're going to subtract 4 because it says decreased by 4. So what would be the new equation? Y equals x minus 8. Okay, so let's see if we were to type those into our calculator, if that would show us a decrease of 4. So let's type in x minus 4 and then x minus 8. And so our calculator is just kind of a double check. The first one is going to be minus 4. The second one's going to be minus 8. You notice how it was minus 4, and did the y-intercept decrease by 4? Yes, sir. All right, so just as a reminder, when the b changes, It changes where it starts on the y-axis, and you can show that by just showing a coordinate plane just on the y-axis, since the B is a shift. And so if the B is bigger, then it shifts up. If the B is smaller, then it shifts down. You guys did a great job on this. Tomorrow we will actually put the change in M and change in B together. Have a wonderful evening.